to another week of In Rhythm's Lightning Talks. For those of you who do not know me, I am Jen Crawford, and I have the pleasure of co-hosting Lightning Talks here at In Rhythm. Lightning Talks happen every week at 5:15 p.m. Eastern, and it is a place for our practice area consultants to come together and teach back to the In Rhythm community and technical community at large on LinkedIn and YouTube, and teach back either something that they're doing on their day-to-day basis, or maybe something that they're doing on the side that they're passionate about. This week, I have the pleasure of co-hosting with Kevin Mongiello, and he will be discussing programming design patterns. So with that being said, let's get the party started, and I'm handing it off to you, Kevin.
Thank you, Jen. How's everybody doing today? I'm really excited.
Great, thank you.
Awesome. All right. I'm really excited to present programming design patterns, code better, easier. Something I think all developers could appreciate. So let's jump right in. Hold on. All right, so let's start off with the introduction. What are we going to cover today, et cetera, et cetera. So the audience is primarily for developers, but it will be simplified enough so that everybody can follow along and understand. And what are we going to be covering? We will cover why, what are the benefits? We're going to talk about abstraction. We're going to talk about making communication easier. We're going to describe Redux super effectively, super efficiently. We're going to learn how to write code better. We're going to learn best practices, a little bit about best practices. And then we're going to talk about kind of everything about, or we're going to list other design patterns that are not included in this presentation. So why should you care about design patterns? Well, number one, understanding design patterns will make you read code easier, write code easier, think about code easier, communicate about code easier, refactor code easier, extend code easier, and there's probably a whole lot of more other easiers that it will do. Let's talk about abstraction first. This is a pretty key principle when talking about the concept of design patterns. So abstraction, when people talk about abstraction, they usually think about like a black box. It's a black box, you can't see inside of it. And so you don't know what's happening inside the black box. All you know is that you use the black box, you maybe have inputs to the black box, and there's some outputs to the black box. And that's all you really care about. You don't really care about the inner mechanisms, the inner components. So the magic is what the black box does. And the knowledge of how it does is not required to use the black box and to talk about the black box and to, take advantage of the black box. In other words, you don't have to go digging in the weeds in order to utilize it. It just works as it does. Also on abstraction, let's have an example. So say, for example, I'm going to give an example of like abstraction. We're going to do it live together. So imagine you're describing a pen to someone else, like a pen, something that you write with. Nobody says, hey, do you have any sealed ink inside of a black tube with a pointed end used for staining rectangular sheets of bleached wood pulp? Nobody says that. I've never, ever heard someone say that in my entire life.
That's how I say it every single time.
I wouldn't be surprised about you. No. Instead, we normally say, do you have a pen? And that's it. Everybody knows and understands the concept of a pen to be able to speak about it easily, to ask for it, to pass it. And you get the point. So a pen is an abstraction. It is a term made up so that people could share a common name for a device or thing that they know how to use and easily communicate about. Nobody cares how a pen works. They just like to write with it. They know what they can do with it. So the pen in this example is the black box. We don't care about the inner mechanisms. We just care how it works. So I said we're going to make communication easier. Let's bring this abstraction concept over to the development world and talk about and give a laborious, labor-intensive description of the pub/sub pattern, which is a design pattern. And so imagine I'm giving somebody a laborious description, and I say, hey, make a class A, that holds a reference to a list. Other classes can tell class A that they want to store a callback function inside that list. When an event occurs that class A is listening for, class A will notify each other class by invoking the functions they stored in the list. Now that's a mouthful. That's really like a lot of words to use when trying to communicate about your program. So an easy description would be to say, hey, let's use the publisher subscriber pattern. And right there with those three words, publisher subscriber pattern, someone who knows what that is will know exactly how it works, and you won't have to go in all the detail and tell them what's at the top of the screen. They just know how it works, and it's a concept that they're familiar with. And so you can use that term to talk and communicate about something very easily, similar to the pen. So now let's take it one step further. Let's describe Redux to someone using this abstraction principle. And I mean, there's a lot of different components to Redux. And so this isn't like an ultimate absolute definition of what Redux is, but for this purposes, just bear with me. Redux uses the pub/sub pattern. View components subscribe to the store for updates. And so I use very few words, but if someone, if someone didn't know about Redux and you described it to them that way, and they knew about the pub/sub pattern, then they would automatically kind of have a pretty good idea of how Redux works. And so that's what I call communication made easy. So I also said that we were going to learn how to write code better. And on the left side of the screen, we have an example of a very complicated program, very, very complex. And in this program, we're getting a favorite animal, and then we're doing some type checking. And then based on that type, we're console logging the sound that the animal makes. Now, this is definitely one valid way to write this program, but it has some pitfalls, it has some downside to it. I mean, this right here is our entire application. If I wanted to extend this and say, log the sound that a giraffe makes, I don't know if they make sounds, but I think that they must, or an elephant or a rhino, then I would have to modify my core application code. So let's use a design pattern to simplify this. So we're going to use Liskov substitution, which is part of the solid principles, which are also considered design patterns. And we're going to reduce all that code on the left to just the code on the right. And we're basically using a common interface on an animal class and have a bunch of animal classes that define a speak method. And so all this class, definition is kind of auxiliary code, and it drastically simplifies our core program logic, right? And so with that design pattern, we have reduced the amount of code that we have to look at in our core function of our program. And so if we have to extend it, if we have to add capability to add more animals, we don't ever have to touch this. We just have to change the animals. We have to add a new animal type, implement the speak method on it, and it will work seamlessly with our core code. We don't have to, worry about breaking our core code. We don't have to worry about, writing additional unit tests. And so this is a great pattern. I love it. And there's probably more that I could say about it, but this is another great example of how just knowing common patterns, you can write better code. So understanding the design patterns that have been, created, refined, optimized, it leads us to get an understanding of what the best practices are. And so by using design patterns, you can easily adopt those best practices. and you don't have to reinvent the wheel. And you can use battle-tested, well-discussed, and refined approaches. And it's easy to weigh the pros and cons of a particular approach because it's already been, like I said, battle-tested. There's people that have already been in, lengthy discussions, refining them, finding where the pitfalls are. And so there's some other design patterns that we didn't cover today. There's lots out there, such as the pub sub pattern. We did mention that today. Solid. There's the solid principles, but you can consider them design patterns. There's the memento pattern, chain of responsibilities pattern, iterator pattern, mediator pattern, state pattern, command pattern, and probably a bunch more. So in summary, learning design patterns is a great way to expand your technical vocabulary, to recognize and understand foreign code quicker. And that's a really important one. If you can quickly recognize a design pattern in somebody else's code, or even your code, if it's code you wrote a long time ago and you don't really remember it quite well, then you can immediately get a really good sense of what's going on, of who has which responsibilities and how the code is supposed to work, because you know the responsibilities and the inputs and outputs of that design pattern. So it helps you recognize code much, much quicker. You won't spend as much time reading code. It'll make your code more easily recognizable and therefore maintainable. You'll be able to communicate bigger ideas more effectively, like I said, without digging into the weeds so much. You'll be able to better comprehend and design program architectures. And you'll be able to leverage what already works rather than reinventing the wheel.